Okay, in this question, the third term of a geometric progression is minus 108. So first of all, we will make data for the given values. The first thing is the third term. Okay, so I can say that the third term means T3. So T3 equals to minus 108, and the sixth term is 32. Sixth term T6, that is equal to 32. Find the common ratio. The first part we have that we want to find the common ratio, and also we want to find the first term, and that is actually a. We want to find the first term and the sum to infinity. Okay, if we look our data, we have two values, and again the same thing, we have two variables that we want to find, a and r, and two equations that are given to you. The first thing is T3 is minus 108. T3. So in a GP, third term T3, that is formula we have Tn equals to a r raised to the power n minus 1. So T3 will become a r square, and this shows that that is according to given condition, it is equal to minus 108. So it means our first equation will become that a r square equals to minus 108. And the second thing, T6. So T6 will be a r5, and what is T6? That is 32. So 32 is a r5. So we have these two simultaneous equations, and as I have told earlier that when we have two simultaneous equations in geometric progression, we would prefer to work with instead of using any substitution or elimination method, we will prefer to work by dividing both terms. That would be easier for you. So if you will divide these two terms, then you will get, so we will divide these two terms. First, the highest power term, that is AR5. So I can say AR raised to the power 5 divided by AR square. That will be 32 divided by minus 108. And if we will simplify them, then what will we get here? This a I can cancel here. So I will say that r raised to the power 3, because it's power 5 and it's power 2, and when we will bring this here, it will be subtracted. So r5 minus 2 will be r3, and that will be equal to, if you will cancel them, 32 and 2 16s are 32, and here will be 2 54s, and again if it's impossible to simplify them, so it will be minus 16 upon 54, right? So now to find the value of r, we will take a cube root, and that will be minus 16 upon 54. Okay, if we will further simplify, we will get that 2 adds a 16 and 2 to 27 is 54. So what will I get here? R, the cube root of 8, I can say it's equal to cube root of minus 8 upon cube root of 27, and that will be cube root of minus 8 is minus 2, and that is 3. So what we get here, that the common ratio R is minus 2 over 3. So that is the one thing. And the second part was we want to find the value, the first term, and we have generated this equation that AR square is minus 108. So AR square equals to minus 108, and we want to find the value of A, and what is R? That is minus 2 upon 3 whole square equals to minus 108. So A times 4 upon 9 will be minus 108. So A will be minus 108 times 9 upon 4. So when we will simplify, what will we get here? Minus 54 So a will be minus 54 times 9, and that will be minus 243. So our second part is a is minus 243. Okay, so now we have the last one. In the last we want to find the sum to infinity. So s infinity is a upon 1 minus r. So what is the value of a here is minus 243 divided by what is r we have find here, and that is actually minus 2 over 3. Okay, so we can cancel them, and what will we get here is 243 times 3 upon 2. 7 will we bring here, it will become multiply. Okay, sorry, one thing here, that it was a 1 minus r. Okay, so we will make some correction here, right? Okay, so please do some correction. So that will be minus 243 upon 1 minus r. So that will be 1 minus 2 upon 3. That will be actually 1 upon 3. So just a minute. Okay, we have done some mistake here, so I will resolve from this portion. Okay, so it was s infinity is a upon 1 minus r. So a is minus 243 upon 1 minus r is minus 2 upon 3. So that will be minus 243 upon 1 plus 2 over 3, and that will be minus 243 upon 5 upon 3, and on simplifying you will get that will be minus 729 divided by 5. So that was the last part. Hope it has solved your problem. However, if you feel any difficulty, please feel free to contact me. Thank you.